You're waiting for that to fall off, aren't you?
Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to make a tool that every machinist wishes they had sooner or later, and that's a vise stop. This is a very simple project, great for beginners, but that's also an opportunity. A simple project like this is a great chance to try out some new things, stretch your legs, try new material, new skill, whatever. This being Blondihacks, I'm going to add so many new and experimental things to this, such as to nearly guarantee failure. But that's how we learn, so let's go. Okay. But before all this, what's a vise stop and what's it for? Well, machining vices are very repeatable in the y-axis, but of course there's nothing to repeat in the x-axis. You can shift the part around anywhere you want. And normally that's fine, but if you want to take this part out and put it back again, and you don't want to lose the features that you've located, say on your DRO or your hand wheels, or if you have multiple parts that are all the same and you want to do a similar feature on each one, then a vise stop will allow you to repeat the X location of those parts, while the fixed jaw continues to allow you to repeat the Y position. A quick and dirty option is a magnetic indicator stand. You can put one of these down, turn on the magnet, and that will give you a pretty decent approximation of a vise stop. That's pretty repeatable as long as you're kind of gentle with it, because you're relying on the magnet and nothing moving here. This setup also takes up a fair amount of room. You've got this indicator stand sticking up here, which might be in the way of the quill, and it's taking up table space here. So if you're working near the end of your table, you might not be able to use this, and so on. So there's lots of reasons why we might want a more compact vise stop that can exist within the work envelope. A common trick you'll see is people drill and tap the end of one vise jaw and then put a little plate on there that can swing in and out of position, and that gives you a nice stop on the end of your vise jaw. And that's useful for a great many things. However, it doesn't allow you to set up a stop anywhere else in the vise jaw. And a lot of vise jaws are hardened, so you may not have the option to drill and tap that. A vise stop is not just for repeating parts, it's also for repeating fixtures. So a very common operation that you'll see is people using a collet block in a vise like this, because it allows you to very easily index 90 degrees or 60 degrees, depending on the shape of your collet block. Now, this all assumes, however, that you're getting the collet block in the same position in the x-axis. Sure, the collet block allows you to index around the x-axis, and again, the fixed jaw is repeating on the y-axis. But if you're not repeating in this way, then you're going to mess up your part. If you're making, say, a square section on the end of a shaft, then the sides of the square are going to be different depths as you rotate this around. So once again, a vise stop allows you to repeat the front edge of the collet block and allow you to very quickly do an operation like this.
Here's my little design for a vise stop. So the rod there moves laterally and it's got spherical ends on it, and then the whole thing clips to the vise with a set screw on the back, and then the larger counterbore screw there is to clamp the rod in place. To the junk pile now to see what I've got to make this out of. I've got some 4140 that's tempting, but ooh, look at this. I've got some 303 stainless here that was donated by a viewer recently, so I think I'll give that a shot. For that, we're going to bust out the anchor lube. It's supposed to be the thing for stainless, so let's give this a shot. So I'm going to mark it to length and cut myself off a chunk here. I've never made anything with stainless before, so this is going to be a little bit of an adventure. So I'm going to set it up in the mill, and I'm going to square it up. Okay, get some machinist toothpaste on there and give this a shot. Now I'm only going to be machining 4 of the 6 sides of this stock, because the nominal dimension of the stock in one axis is actually the same as I want for my final part, and the thing doesn't have to be machined all the way around, so I'm going to leave it rough and I'll just clean it up later on the buffing wheel. Let's see how those first cuts ever on stainless came out, and finish is nice. I got a little bit of a step there. I'm not sure where that's coming from, but I'll flip the part over, do the other side, and I'm going to bring it to dimension on this axis. Now, of course, because I'm not machining the 2 sides that are currently on the vise jaws, this is not, of course, the proper method for squaring up stock, but this is, again, not a super precision part, and this is going to be just fine. I experimented with depth of cut as I went along, and I can definitely feel the toughness of the stainless here. I can't do as deep a cut as I would with mild steel. And I have this convenient vibration sensor on my mill in the form of a block of wood on the sheet metal. You're waiting for that to fall off, aren't you? I know you're waiting for it. Oh, the cut's finished. Oh, it didn't fall off. Okay, here. Are you not entertained? And I'll check and see how much I have left to remove by using a depth mic down to the parallel. This is not the most precise way to do this because you are assuming a lot about how the part is sitting on the parallel, but it's going to be close enough for this part. And I got a little more to go, so I'll do a finishing pass on this edge. Okay, so far so good. I'll clean up my toys here, and let's pull that out of there and give it a quick deburr, and I'll measure it and see how we did dimensionally, and this will give us a sense of how accurate that micrometer method is. And you can see that I'm aiming for 750, and I'm about 2 thou over, but I'm the same at both ends, so at least there's no taper, but you can see how that micrometer to the parallel method is a little prone to error. I'll move it to the end now and side mill the ends square. You don't ever want to do a heavy operation with the part at one end of the vise like this because it's not held as securely as it would be in the center because the vise jaws can get a little crooked. That finish is nice, so now I can flip it around and clean up the other end and bring it to length. And I'm just using my scale here to check and make sure that when the part is at final length, I won't be hitting the vise with the end mill. Got a little ways to go here, so I'm doing multiple passes. And again, because I'm clamped on the end of the vise, I don't want to get too aggressive with the cuts here, so I just did a lot of light passes. Okay, that should be it. The guessometers will be sufficient precision here on this part, so I'll check my dimension there, and we are 1 thou over, which that is going to do fine. So now I can deburr all the edges. I'm using this little Noga blade tool here, which I like very much for deburring parts. Does a really nice job. There's a link to this tool down below. The next thing I'm going to do is the hardest feature on the part, and I'm going to do it now in case I screw it up. I haven't gotten very far into the part here if I scrap it. Now, it's always a good idea to design for manufacture when you're designing things, so here's a great example of how not to do that. I need to make this feature here, and it's basically 3 concentric holes of different diameters. It's threaded 632 here, and then it's 632 clearance here, and then counterbored for the head of a 632 cap screw. This detail here is especially tricky because the split line has to land right on the transition between the threaded area and the clearance area, and of course drills have a point on them, so the base of the drill point, the widest part, has to land right on that split line for this to work. And we need to stop 20 thou short of the far side of the part. So we have a very deep hole, of very small diameter, in stainless mind you, with very little margin for error at the end. This is going to be difficult. But Quinn, you said this was a beginner project. Well, if you want to do this easier, just drill this straight through and it'll be much, much simpler. I just wanted to have the nice clean front on the tool. Or you could have the clamping bolt come in from the front, which would probably make all of this a lot easier. But again, I wanted a clean look and I'm trying to stretch my skills here. So I've got it set up vertically in the vise and I need to make sure it's very vertical. So I'm indicating it in here, and I've got a piece of copper bar there that I'm using to reach in there and tap it straight. I need to be pretty straight here because it's a very long hole, so if it's even a little bit crooked, it's going to be pretty far off by the time we get to the other end. So now we are within a couple of tenths there of perfectly vertical. I think that is going to be sufficient. Now I'm going to edge find to get the center on the x-axis, and then I'm going to edge find the near edge to get the position of the holes that we need to make here in the y-axis. And I'm dialing in 350 on the Y, and this little jiggling back and forth you see is me trying to get it to land on the right numbers with the table locks all set, because I want both table locks fully locked for all of the things that we're about to do. I'll start by center drilling here, and the rule of thumb with drilling in stainless is don't linger. Get in, do your business, get out. If you linger at all and the drill rubs, the stainless will instantly work harden, and then you're toast. I'm going to take this moment to reinstall the depth stop on my quill. I don't leave it installed because it takes up valuable space there in the work area, but it is going to be very useful here. So I'm going to start with the tapping drill size for 632 for the thread that's at the very bottom of the hole. So I'm just going to lightly touch the work, zero that DRO on the quill, and then set my depth and check on the side here of the part to see how we're doing. It's a little too deep, so I moved it up a little bit. Again, we want to come just shy of breaking through that far surface, and then get lots and lots of toothpaste on there, and here goes nothing. Again, this is a very high aspect ratio hole, so it's going to want to pack up with chips, and when drills pack up with chips, that's when they start rubbing, and then that's going to work harden that stainless, and if it work hardens, we're done. This part's scrap. So it's all about getting in, get some depth. As soon as you feel those chips starting to pack up, get out, clear the chips, get back in again. Get in, do your business, get out. Okay, that worked pretty well, I think. So I'm just double checking my depth here with the drill off, and we got to where we needed to be, so that's good. Now I need to widen out the upper part of the hole for the clearance. So I'm using a 20 thou feeler gauge to zero my quill DRO, and then I can just add 20 thou to my depth, and we should end up in the right place. This hole is much easier to drill because we're just opening up an existing hole, so not too much risk of work hardening the stainless there. Out with the Jacob's chuck and in with an end mill now to make the counter bore. Bring the head down nice and close. You always want the head close to the work and locked. And then I'm going to go in and do that counter bore. This was a very easy operation. This is a nice sharp carbide end mill, but chip control was a bit of an issue, so I had to stop periodically and clear the rat's nest out of there. But this counter bore seemed to go very well. These are all new operations for me in stainless, so I didn't know how some of this was going to go. What's that? Compressed air in the Blondihacks shop? I know, I don't usually use it. I do have a small compressor though, and I busted it out of storage just for this job because it's really important to get the chips out of that very deep hole that I'm about to thread. The number one thing that causes taps to jam up and break is chips jamming up in there, so I want to really make sure that there's no chips in there. Now, you saw me go in with the taper tap, and it bottomed out immediately because this hole is so shallow at the bottom, so I had to go back in with the bottoming tap. The blind hole at the bottom only has about 3 threads in it, basically the minimum I could get away with, so we don't have a lot of wiggle room there. But blowing out the chips again and going back in will often buy you an extra thread. In this case, it did, so do a little test fit here with the bolt, and that looks good. It's threading in. Now, this bolt is too long, so it's not going to thread all the way down, but the threads are down there, and they seem to, well, exist. Okay, now I can center drill and set up to drill the 632 set screw that's going to clamp this thing to the vise jaw. And this part is much easier because we just have to drill sufficiently deep to get into where the cutout area in the middle will be. And that is all looking very good. So I'm going to turn it sideways now, edge find again, and center drill. And now we're going to drill the through hole for the sliding bar. And again, get in, do your business, get out. Get in, do your business, get out. Drilling stainless is one of the most challenging things according to real machinists, and I can see why. So I drilled that undersize, and now I'm going to come in with my 3/16 reamer, and I'm going to just ream this to final dimension. And this seems to be going just fine. Lots of toothpaste again. Deburr that hole. I'm going to leave that set up in the mill now just like it is, and I'm going to go make the bar now so that we can fit the two together if need be. So mark that for length, and I'm going to build some character and use the hacksaw for this. Over to the lathe now, and I'm going to face off the ends of that bar, get them nice and square and clean. And I'm going to break the corner with a file just to make sure there's no burr on there, but I'm not going to chamfer it because I need that surface to be nice and flat with no rounded edge on it here, as we'll see. And then I check the length and flip it around and face it down to the final length that we need. And now we can do a test fit in the hole, and it doesn't quite go in. It's very close, but not quite. So measuring the bar here, and we can see that it is 1/2 thou over 3/16, which is typical for the drill rod that you buy, which is good. That means our reamer actually cut right on size. So I've got the over-under reamer set here. I'm going to grab the oversize one, and as you can see, it's clearly 1 thou oversize, and I'm just going to open this hole up 1 thou. And you would swear that nothing happened when you do this, but now check that out. Mercy, that's a perfect fit. Oh, that's an RC3 all day, maybe even RC2. Over-under reamers are the secret to looking like a hero in a hobby shop. Deburr, deburr, deburr. This tool, by the way, is part of the same set that the blade tool I showed earlier is in, so check out the link down in the description below. Okay, we're ready to cut the slot down the center of the part now. So I got it set up on the wide side, and I'm just double checking, make sure I've got enough sticking up that I'm not going to hit the vise jaw. That looks good. And I'll edge find on that edge once more and bring my end mill into the middle of my slot. When you're slot cutting, you always want to do the middle part first and then work your way out for a good finish. And ooh, that is squealing like crazy. I don't like that at all. So I slowed down the RPM and came back in, and that sounds much, much better. I think if the RPM was too high, the front edge of the cut is work hardening. If you look in the big book, the surface speed for stainless is always a little lower than mild steel, and I think this is why. So I worked my way down to final depth on the center of the slot in multiple passes. I think I did 40 thou each pass, which is less than I would do on mild steel, but that seemed to be where the stainless was happy. And then I deburr that and check my final depth. That's looking good. So now I want to see how much I have to take off of this side. And so I'm just side milling now to remove the extra on that side. And then once that width is good, then I go back and I do the same on the other side. So you notice that I'm cutting back to front on one side and front to back on the other, so that we are always conventional milling and never climb milling. Next, I'm going to make this a high value part by chamfering everything with this 2-flute chamfering mill. It's a very nice little piece of kit. Chamfering everything will just make it nicer to handle and it'll look nicer, and yeah, chamfers just make the world a better place. The exact dimension of these chamfers doesn't matter, so I'm just touching off with the tool and then moving on the X the same amount each time, and as long as you don't move the tool vertically, then all of the chamfers will come out looking the same. That's looking pretty good. A little deburring to do, but here's a little test fit now, and that fit on there is really nice. There's a 10 thou clearance on that, so it slides really nicely. Now, a little mechanical design lesson here. This corner here should actually be relieved because any inside corner always has a tiny, tiny fillet in it. It might be so small that you can't see it, but that little fillet will keep an inside corner from seating on a square outside corner. Now, a typical way to get around this is to just cut a slit in there with something like a slitting saw, as I've shown here in the model. Now, the back corner doesn't need that because that corner of the vise is chamfered, but I'm not going to bother doing that because this isn't a high precision part. It doesn't need to seat perfectly on the vise jaw down to the micron. But if you look at precision fixtures like V-blocks, you'll always see that relief cut in the bottom, and that's why. Next thing to do is set up a little slitting saw here, and I'm going to cut the slit in the hole that holds the bar so that it will clamp on the bar. So I squared up the part, and I need to know how thick my saw is so I can get it centered on the hole. That looks good. Now, here's the problem with slitting saws, at least on this arbor that I have, and there's never clearance above the vise for it. So you always end up needing to reset the part on the end of the vise, as I've done here. And now I'm measuring up some packing to put in the far end of the vise because this is going to be a pretty heavy cut, and so I don't want the vise jaw to be canted in this case. So my packing is a couple thou smaller than the part so that the part is sure to be clamped tighter. That's important. And then to find the top of the part, I'm using a feeler gauge. You can also touch off with a slitting saw, but I don't want to mar up the top surface here, so I'm using a feeler. And then I add 10 thou, plus the distance that I want, plus half the thickness of the slitting saw, and that will be right on the center line of my hole. Little sanity check, and that looks good. And at the last second, I remembered actually it's this side that needs to have the slit in it. That was a close one. And then I touch off with the saw, and then set up to make the cut. A little toothpaste on there. Recently, a real machinist told me that you always want to do a full depth cut in one pass with a slitting saw because that gets the most possible teeth engaged because these saws always have run out in them. So if you do a light cut, you're only getting 1 or 2 teeth. And these saws are also designed to clear their chips in a deep slot like this. So they really do perform best if you do it in one pass. And that's honestly kind of terrifying, especially on a small mill like this, but it really does work. And it's some of the best advice I ever got for slitting saws. So that operation went really well. I wasn't sure how it was going to go. Again, this is stainless. It's all new to me, but it went perfectly. And now we can test that clamping action on the bar to see if it's going to work. So I've got washers in there so that the bolt head has something to clamp against, and that looks like it's going to work. The clamping action is working there, so we did get enough threads at the bottom of that deep blind hole, and the washers will help me figure out how long this bolt needs to be. So I ground this down to length using the thickness of the washers and the depth of the counter bore, and that threads in there nicely. Let's see if it actually clamps on that bar, and it does. It clamps. It feels a little mushy, which is weird, but yeah, I gotta clamp it pretty hard, and it doesn't feel solid, which is strange, but it is working. So, okay, yeah, that's clamping the bar. But after a couple of loosening and tightening cycles, it got stuck. It wouldn't come out, it wouldn't unthread, and it was thoroughly wedged in there. So, did I just scrap this part by getting a bolt stuck in it? I said a prayer to metallic ore, the god of machining, and I tried super gluing an Allen key in there, let it set up nice and strong, and it worked. It came out. Whew. Boy, that was scary. And a little bit of heat from the torch separated the wrench, and we're back in business. So what's happening here? Well, a closer look at the bolt reveals that the threads are shearing off. Now, there's only 3 threads at the bottom of that hole, so we're asking a lot of them, and this bolt is just cheap. So I went on McMaster Carr and I bought some quality bolts, and you can see the difference. The cheap ones that I bought on Amazon are at the top, and the good quality McMaster ones are below, and you can just see the difference in quality on those threads. And with the McMaster Carr bolt in there, it's night and day. Like, it feels solid, nothing's mushy, and you can tell that it's clamping solid. Oh, it's great. The last thing I'll do on this part is take it to the Scotch-Brite deburring wheel. This is the secret weapon for looking like a hero on Machinist YouTube. So I'm especially going to use it on the top and bottom because, as you recall, I didn't machine those surfaces, so they were rough from the factory, and I didn't get all the pitting out, but gosh, that Scotch-Brite wheel sure does make anyone look like a real machinist. Now, my design calls for spherical ends on the bar, so we'll do that next, and this is not strictly necessary, it's just kind of an extra fancy thing I wanted to try. And for this, I'm going to use ball bearings, and ball bearings are great for precision setups, so don't ever throw old ones away, because they're perfectly spherical and they're very hard, so they will only contact your part in one place, and they don't wear out or get pitted because they're hardened. So the ball bearing sits in a dish feature on the end of the rod. Now, you could easily make that dish feature with a ball nose end mill, but I don't have one, so I'm going to get fancy. I got a piece of high-speed steel in the scrap bin here. I'm going to cut the end off of it. It's an old center drill. And I'm going to go over to the D-bit grinder, and I'm going to make a single flute ball nose end mill. So I'm splitting the stock here in half, and once I've got that split, then I can go and make a clearance around the back, and then I clearance on the front, and then I can grind a radius the same as the diameter of the cutter. Now, I did a video on how to use a D-bit grinder. If you want to know exactly what all I'm doing here, I'm not going to try to cover that again here. And a quick cleanup deburr on the stone, and that is our single flute ball nose end mill. It's not going to win any beauty contests. I have a lot to learn about this machine, but it is going to work. I kind of just ground the corner off the back there because I couldn't get the angle right, and the radius doesn't quite line up. It didn't blend into the edge. The radius is actually a little bit too large, but I did a test cut here on a piece of aluminum just to see how it's going to work, and it's certainly cutting nice. The finish is good, and it is going to fit our ball bearing, but you can see there how the radius is slightly larger than the ball bearing, but that's going to be okay. I misconfigured something on the D-bit grinder. It's a complicated machine. I'm going to make this cut in the lathe. And these pins are actually too small for my 4-jaw chuck. The jaws bottom out on each other, so that's why I'm holding it in a split chunk of aluminum. Then it's really important to get these parts dialed in really, really well, because if that dish feature that we're cutting isn't perfectly centered, then when the ball bearing is sitting in it, it's not going to go through the bore on the clamp part, because we only have about a thou of clearance there. The ball and the bar are exactly the dimension that they need to be, pretty much. So really important to get this centered, and wow, well, I guess that ought to do it. I'm going to hold the cutter in my Jacob's chuck, which is fine because it used to be a center drill, unlike, end mills or taps, which you really shouldn't put in Jacob's chucks because they're too hard. Now, this is a form tool, so I'm trying to feed very, very gently. It does really want to chatter, of course. Okay, that looks okay. Let's see how the ball fits, and yeah, it fits about as well as we expected. Not awesome, but the tool actually flared the end of the bar a little bit, so it doesn't fit through the hole anymore. So I'll just clean up that flare with a file. And now that fits in there good. So now I can clean everything up with acetone because I'm going to try Loctite 603 to glue the balls in place. Loctite 603 has never let me down. So I set it up like that between those blocks, left it overnight to cure, and that didn't work at all. It looks like the Loctite ran out of the joint before it cured, so I'm going to try the same thing but set up vertically this time, so the Loctite has nowhere to go, and that also just didn't work. Loctite 603 is amazing stuff, but it is intended for press fits, so it cures in the absence of oxygen. Still, I've had it work in cases like this before, but not this time. So regular old super glue is my final attempt. This cures with moisture from the air, and that worked just fine. I think that's going to work. And a quick test fit, and yeah, it doesn't really fit anymore, so the super glue must have pushed the ball slightly offline, and then the ball broke loose as I pushed it through. So I just glued that ball back on, and we'll call that a captive bar now. Those balls may not stay there. That super glue is not a great hold on there. These polished machined surfaces just don't hold glue, but yeah, if this doesn't work, I'll try something else later. I could solder them on, or you could just round the ends of the bars with a form tool, something like that. I wanted to be fancy and use the ball bearing, but that's super not necessary for this. Now, to mount this unit on the vise, I'm going to use brass-tipped set screws. These are really cool things when you don't want to mar up the thing that you're clamping to. Let's do a little test fit here, and that looks really good. And then we can slide the bar into whatever position we need. And yeah, that looks good. It's gonna act as a vise stop. I'm pretty happy with that. And you can also use it on the side of the jaw on this vise. Even though it's not fully seated, the set screw there still has purchase, so that works for parts that are deep in the vise like that. And then for collet blocks, you can set it up on the back like that, and that repeats very well. Now it's not perfect. If you take a look around the back here, you can see that it's actually seating on the closer ring and not the collet block itself, which would have been better. There just isn't room back there for it to reach into where the actual surface of the block is, but this is still going to work just fine. And that is it. That's our little vise stop. I hope you enjoyed watching this get made. I hope you will make some version of this yourself. Thank you very much for watching. Throw me some love on Patreon if you like what I'm doing here, and we'll see you next time.